What are SuDS? Sustainable drainage systems. So when we have intense or prolonged rainfall, this generates runoff, and it must be managed on the site, otherwise it will lead to flooding downstream. SuDS systems, sustainable drainage, are an alternative to the traditional concrete and pipe systems for controlling runoff. And along with the controlling of flood risk downstream, they also have multiple other benefits in terms of amenity, water quality, etc. So the aim of a SuDS system is to replicate the natural drainage from the site before it was developed, so reduce the runoff and flood risk, and also to improve water quality, amenity and biodiversity. SuDS systems comprise of a number of different elements at different scales across the site. So you'll have the source control element, which is basically at the building, permeable paving, water butts, reduction of impermeable surfaces. And then as the water moves through the site, you'll have a bigger scale site control, and then maybe a regional control. And at each point, you're trying to slow the water down to stop it running off. You're trying to infiltrate as much as you can into the ground and prevent an increase in flow downstream. So to set the context for SuDS, just a couple of slides here. On the left, that's January 2014. That's percentage long-term average rainfall. And the dark blue area is more than 200%. So you can see the very wet winter we had in 13-14. There was extensive flooding in the south of England. And then on the right-hand side, you can see the last winter, December 2015. A similar pattern, but now across the north of England. It's up to 300% long-term average rainfall. So this just sets the scene. You know, extreme rainfall events are happening now. It's not something off in the future, and they can happen anywhere in the country. It just depends on the storm track, etc. So, you know, it's a reality. It's not something in the future, and climate change will make that worse. So that's something to take away, and we need to do something about it. We can't ignore it, and SuDS can be one of the solutions for managing this. Why are they important? So development increases the hard standing and impermeable surfaces, reduces the permeability of soil, so you get a lot more runoff, you get less evaporation and evapotranspiration from the vegetation. Our current drainage systems and sewers, many of them are Victorian. They have limited capacity, and we can't just keep sending the runoff down the sewer. It's not going to work. So we need to do something about that. And it's only going to get worse in the future. We've got more development. The population is expanding, so we need more housing. And we've got climate change predictions indicating more extreme weather. So we've got a lot of runoff now, and we're going to get more, and the existing sewer system is not going to cope with it. SuDS could be the answer. So this is my favourite slide of all of it. This is encapsulates the science part of it. On the top left-hand corner, we've got the undeveloped site, so we'll get a rainfall event on that. It'll be intercepted as it flows across the surface by the vegetation. Some of it will be taken up by the plants and evaporated. A lot of it will infiltrate into the ground and join the groundwater system underneath, and then emerge in the river at some later date as base flow. So that's the pre-development condition. And then on the right-hand side, the top right corner, we have the urbanised situation. So you can see there's more than 50% of the area is covered by tarmac and hard standing, so that will be basically nearly 100% runoff from that. We've got evapotranspiration is much more limited, and so this results in a higher runoff and a lot lower recharge to the underlying groundwater system. So if we look at the graphs underneath, these are hydrographs. So the y-axis is a flow, and the x-axis along the bottom, that's time. And these are from a watercourse adjacent to the schematics above. So for a rainfall event, if we look in the bottom left-hand corner, that would be the natural situation. You would get a gradual peak in the flow in the river, and then it would tail off. But if we look on the right-hand graph, that red dotted line, This is the runoff and flow in that river under the urbanised condition. So you can see you get a lot higher peak flow, so higher peak, and then the area under that graph is bigger, which represents the volume. So you get higher flows and greater volumes running off the site, and that naturally leads to greater flood risk downstream. So the aim of SuDS is to recreate that as closely as possible, that the blue dotted line, the hydrograph for the natural runoff. So you're trying to reduce the peak flow off the site and reduce the total volume off the site. And I think this sort of encapsulates what SuDS are about in terms of the flood risk. So SuDS mimic the drainage that was there before the development. So we're aiming to try and recreate, if we can, that blue dotted, less peaky runoff. But they also have other benefits which we'll come to later on. They comprise a series of components at different scales as the water moves across the site. So we have prevention, water butts, grass roofs, grass areas, rainwater gardens, etc. We've got source control, which is just sort of a slightly downstream. And then any water that's not dealt with there will have to be moved through the site to its ultimate discharge point. So that may, instead of sending it through pipes underground, we move it through swales and through storage basins, etc. And on the site scale, we might need to provide some storage to hold that water while we infiltrate it or while we discharge it at a controlled rate. That would be the basins, etc. And then it'd be more regional scale control. We might get all our network feeding into one main discharge point or basin. So a series of elements of different types that are assembled either in a train or individually put together as these individual SuDS components. And I'll quickly run through the types of those. So here we've got, on the left-hand side, that's a swale, and on the right-hand side, a linear wetland. So these provide storage for the water within them. They convey the water across the site. They provide a natural attenuation and improvement in water quality by passing through the vegetation, and they also offer amenity value. They can be integrated with the landscaping. They can offer biodiversity effects. So the whole idea of SuDS is flood risk, but also integrated with these other benefits, which can support their use and within the development. But it also does mean that these have a different type of maintenance requirement for the site owner. So these will need to be mowed, etc. But that can be incorporated within, the landscaping in general and the maintenance of the green areas of a site. So it's not an insurmountable part of it. So national planning policy practice states there's a hierarchy of drainage. So the optimum drainage is to put the water into the ground and don't allow it to leave the site. That depends on the ground conditions. Obviously, if you're on the London clay, it's going to be difficult to infiltrate all of the water. But you need to have examined the ground option before you can then move to the next option, which is discharging to a surface water course or surface water body. But that depends on your access to that. If you can't put it into the surface water course, then you can look at a sewer or a highway drain. And if you can't go in there, then you can look at the combined sewer. But there's this hierarchy which any assessment from a site you must go through. Start at one, can I do it or not, and then move down the drainage hierarchy. This is a typical infiltration basin, just to give you an idea. So obviously, when you get intense rainfall, it's not going to soak away straight away. So you need somewhere to hold it in storage to allow it time to seep into the ground. So typically this will be dry for most of the time. The SuDS systems are designed for extreme rainfall to the 1 in 100-year event, something like that. So most of the time this space can be used as part of the amenity space within the development. But it's designed in such a way that it will fill up as necessary to provide this storage and then gradual infiltration into the ground underneath. So retention basins and ponds. So these can be designed. These are designed to hold the water and allow slow release either into the ground or off-site to a watercourse. They can be designed to be wet or dry. It depends on your landscape architect, etc., and the local site conditions. So most of the time, If you want it, it can be dry and used for amenity, or it can be a water feature and provide other amenity benefits. And then there will be, in some cases, if it can't infiltrate to the ground, there'll be a control on the outfall from the pond, which will limit the maximum rate that water can move off the site. And that's all part of the SuDS design. So this is a typical site layout on the right there. So each house would have had its own source control measures, hopefully built in with it. It might be permeable paving, rain butts, etc. And then you can see the blue lines provide any water that's not dealt with on site has to be conveyed through the system. So the SuDS way would be to use swales and these open surface systems, if possible. So that would be conveyed through the site to the pond at the bottom, which would be the sort of the final site control measure. So that would be designed to have enough storage to cope with the 1 in 100 year or the 1 in 30 year rainfall event. And then it would allow a controlled discharge rate. So you would agree the maximum discharge with the planning through the planning application process to the adjacent watercourse. So there'll be a control on the outfall from that lake, which would be designed to a certain specification and agreed. But you can see it discharges to the surface watercourse. It goes across adjacent neighbouring land. So that would be a requirement to negotiate access to that land, possibly with another landowner, to establish the discharge point to that stream. So that's a typical consideration. And you also note that perhaps previously a developer might have put houses across the whole site, whereas in this case he may have lost some of his housing development to some of the SuDS elements. But then on the other side, he might have, could sell his houses for more. It helps sell the development, etc. So there's benefits to SuDS and also, potential things you have to watch out for. So SuDS could impact on site layout, site density, construction costs, construction time, maintenance liabilities, so the ongoing looking after the various systems, future value of the site, neighbouring land and access across the site. But as I said, SuDS also possibly have multiple benefits, which are more difficult to put an exact cost on. They improve water quality leaving the site, amenity biodiversity, water resources. They can be integrated in the landscaping of the site to make a nicer place to live, and they could actually enable development if the local planning authority is imposing requirements for SuDS, then putting them in may enable your site to get planning permission. So there's a few things to think about there on the benefits of SuDS. So understanding a site's suitability for SuDS will depend on various different factors, but I think your clients should be aware of what SuDS are and the potential implications that they have when they're buying property, whether it's just buying a property or for future development. They should be aware of what SuDS are and the implications. It's particularly relevant where the site's in an area of flood risk or for major developments, but indeed they're relevant for all developments, and I think my colleagues will talk about that as we go through this. So in terms of advising lawyers, I would say it's in your client's commercial interest to understand SuDS and their implications and for the value of the site. And it would help discharge a lawyer's duty of care on drainage matters, etc., during the due diligence process and acquisition.